Audio Jungle.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alif Imran, and now I will show you the simulation of experiment 2 activity 1. The first simulation is we use the resistor 210 ohms, and then we run the simulation, and then we get the watt, and this is the watt. Next simulation is we change the resistor to 10 ohms to 390 ohms. And then we run the simulation. Start. This is the what we get, and that's done the simulation. Second simulation, and then stop. And then the third simulation, we change the ohms to 470 ohms, and then we start the simulation, and then we get the watt for the simulation. This is the watt. Stop the simulation, and then the next simulation is at 60 ohms, and then we start the simulation, and we get the ohms. This is the ohm. This is the watt. Next simulation, now we have two resistors right now. We have the first resistor is 210 ohm, and then second resistor is 470 ohm, and it should be in a series circuit. Then we start the simulation, and then we get the 14.706 watt, and stop. Next, the next simulation is we change the second resistor from 470 to 860 ohms. Then we start the simulation, and then we get the watt, 9.346 watt. Stop simulation. Next simulation is the parallel circuit with two resistors. The first resistor is 210 ohms, and then the second is 470 ohms, and then we start the simulation, and then we get the measurement of the wattmeter. We get 68.896 watt. Stop the simulation. Next simulation, the second resistor we change it to from 470 to 860 ohms, and then we start the simulation, and we get the watt here, the power here, and then stop. Thanks.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aizil Fikri Raslam. Want to proceed for the activity 2, experiment 2. As we see, this is the connection of the circuit for activity 2. We have a 100 volt AC voltage, and the frequency is 50 Hz. We also have a resistor and the inductance. So as we see, from the table 2.2, the value of resistor and inductance have the different value for each activity, and then we just arrange the connection for the circuit by using multisim, Proteus, and any other simulation. So for this lab, I use multisim for the simulation. Okay, so this is a multisim simulation. I have arranged the circuit from the lab sheet. Okay, so here we have AC voltage 100 volt for the setting, and the frequency is 50 Hz. Then click OK, and we have the value for the resistor 210 ohm. Double click. Okay, 210 ohm. Then click OK, and also for the value of inductance 0.4 Henry. Then click OK. Also we have ground for the circuit and the wattmeter. So we run the simulation. So as we see, if we have error by the connection, we must have the warning here, and then there is no warning, then the circuit connection is okay. So we double click the wattmeter, okay, to see the value of power, also power factor for the circuit. So the power from the circuit is 34.822 watt. Okay, by this we get the value of the power and power factor. Then from the lab sheet, we open the lab sheet. We need to find the value of Q. So how we want to find the value of Q? So here I have made a calculation. Okay, recently we have the value of power from the circuit, which is 34.822 watt, and the power factor value is 0.85514. So this is the value of the power factor, and this is cos theta. So we want find theta in this problem. So we put the value of power factor 0.85514 equal to cos theta. Then theta equal to shift cos times by 0.85514. Then we get the theta, which is 31.225. Then how we want to find the value of Q? This is the formula: tangent theta times by power. So tangent, we put the value of theta 31.225 times by power, which is 34.822 watt. So we have the value of the Q. Then we put the 21.110 into the lab. This is the connection for the circuit. So we have a six number of activities. We put the value of resistor and inductance by changing this resistor and inductance for the simulation. Then we can get the value of number 2, the measured value of Q 33.373, and 1021.891, 1.0685, 3.165, and also for the last 3.785. So this is the measured value for Q that we find from the simulation. Then we go through for the value of impedance, also for the calculated value Q. this calculated value, we just using our formula here that has given in the lab sheet. Okay, that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq. So next, we move to activity 3. As you can see here, the circuit is slightly different with the activity above. So here we can simply say that we must change the polarity so that the answer will get negative. Okay, so this is the table for ourselves to measure the value by insert the load given. So let's we move to the simulation. This simulation is made by Multisim. Okay, as you can see here, this my circuit that I have arranged based on the lab sheet. Okay, first we must of course arrange the power, the AC power, the wattmeter, resistor and capacitor. So here I show you how to simulate this circuit. So for the first load given is the resistor is 210 and the capacitor is 2 micro. So let's we just run the simulation and check the value. It will pop up like this. Okay, as you can see here, this is the power value, and this is power factor. Okay, to take the value of the measured value, we must do some calculation based on this power factor given, and we can insert it into our formula to find the theta and so on. And I have shown this calculation in the lab sheet. Okay, so this is the first load. Okay, the first load given. So how to get a different value? We just simply insert the load given. Okay, let's we try for number 3. The load number 3. Load number 3 is okay. 210. Okay, and the capacitor is 8 micro. Okay, let's we run the simulation. We can see here that the power is negative 10.427 watt, and it's the power factor. And like I said before, we can simply find the measured value by insert these both values into the formula, and we can get the measured value. Okay. Okay, next I will show you the load given for number 6. Okay, we change this. Change the value by the load given, which is 860, and enter. Then the capacitor given is 8 micro. Okay, so we run again the simulation and see the value. Okay, this is the final value. Okay, it's the power for the circuit, which is negative 9.589 watt. Is the power factor. Okay, this is how we simulate this activity 3 circuit. And thanks. That's all from me. Thank you.